Back, we're live, we're here on Likable Science, because science is more than likable, it's lovable, okay? And here's Ethan Allen, he's the host. There he is.
Thank you, Jay. Good to be here.
And Ethan is a scientist. I mean, what more appropriate person to have on a show about likable science? But before that, the news. So we had this thing last night called ThinkTech United.
Super event.
Okay?
Super event.
And it was really interesting. I was tired, but it invigorated me anyway.
Oh,
And gee whiz, we had some great speakers there, giving testimony about ThinkTech. It was good.
Including the producer of this show, Zuri.
Including Zuri. Zuri, why don't you get on the console mic and give your impressions of how it went?
Oh, you guys are so sweet. Of course, you put me up for a surprise. I just want to say thank you so much for such a wonderful event.
Outstanding, and your remarks are outstanding. I
Absolutely.
told you that.
Absolutely. She did great.
And we had, we had a lot of comments from people who were close to the organization. A lot of people showed up. That was great. Food was good. My wife told me, because I don't eat at these events.
It's wonderful.
And everything was well organized.
Great.
Carol Monlee is just fabulous.
Great
And
company.
well, she's fabulous. And then I think, Robbie Aum was wonderful.
Yes, absolutely.
And it's so important to really hear what he has to say.
Yeah.
Because he speaks on about 3 levels.
Right.
And so we have it all on tape. We're going to make an OC16 show out of it.
Cool,
Play
excellent.
it in a couple of weeks.
Look forward to
Everything.
revisiting it then.
That was fun. So we'll do it again next year.
All right.
It's too exhausting more than once a year. Okay, well, anyway, and thanks to Kali'i Rosa, who is the guy who set it up at Lani Akea. He's very good. We work with him all the time, and he did a good job.
Beautiful venue, too, yes.
And I could go on. There are other people I want to thank, too, and I'll hold up. So anyway, let's talk about learning, because we titled this thing Learning About Learning, and I faked you out about that because it's more than learning we're learning about. It's mental process.
Okay.
So, this is like years ago on HPR, we had a call. We were talking about computers. We had a call from this guy who was a friend of the show. He called all the time, but today I think he was drinking, and he called and he said, "You guys are talking about computers. You can't talk about computers unless you give me the basics. I need to know about electricity. You're going to tell me how electricity works." So I turned to the guest and I said, "This one's for you." we never let that caller in again. But anyway, so my question to you is, so how does the brain work, actually? Your answer would be with electricity, Jay.
Very good. A little chemistry, a little electricity, yeah. The brain basically has, several billion cells, each of which has many thousands, tens to hundreds of thousands of connections to other cells. They're tied into all of our sense organs, and presto changeo. We perceive the world around us, we take in stimuli, we filter out huge amounts of the world around us so that we can think about it, we analyze it, and we behave appropriately.
Yeah.
That's
Well, we're going to exclude from the discussion today all those autonomous things that happen to make our liver behave properly. Okay, that's another show.
Sure.
Certainly just as important.
Sure.
But I like to talk about the higher levels, the thought levels. And, one of them is learning, and there's lots of other things we can talk about. But let's start with how the mechanics work to actually give us consciousness. That's not an easy question either.
No, that is not. That indeed is sometimes said to be the one big sort of ultimate question that neuroscience may not be able to answer, is sort of why and how are we conscious?
And what is consciousness?
Yes, right.
I know some people I don't think they are, actually.
It's true. There's very interesting data coming out these days, though. People who appear to be in vegetative states and have been thought to be completely unaware of their surroundings have now been put into functional MRI machines and been given instructions, for instance, to imagine yourself playing tennis. And these people's brains behave very much, in some cases at least, the way a normal person's brain would under the same circumstance, that is lying on a bed being asked to think about playing tennis. The same parts of their brain will light up. They'll be going through apparently the same kinds of rehearsing, the same kinds of motions, making the same kinds of decisions.
Even though they're asleep, even though you can't talk to them.
Right, even though they appear to be completely unresponsive, they're locked in lots of ways, but that does not mean they are really unaware. They apparently can, in some cases, can hear perfectly well, can think perfectly clearly, can envision themselves in a regular world situation. So it's a very interesting.
And there were gradations of that. I
Yes,
mean, we knew
exactly.
there was an artist here. She had Lou Gehrig's disease, and little by little, she lost the ability to use her body. And well, she was very smart. She was still capable of communicating. She had this device with a kind of pen, and the pen would touch a keypad, and she'd be able to type out words, even though she wasn't able to move any part of her body. It was quite interesting. And clearly in that case, that was consciousness.
Right.
What you're taking it a step further.
Right.
You're saying that consciousness can be even while you're unconscious.
Yes, that simply being unresponsive does not mean you're unconscious in any sense.
Yeah. You
So
can't
it's
display it. So then let's define it. It's the ability to think. Is it that simple?
well, again, it's sort of a gray area. I have some companion parrots, and these birds clearly think. Are they conscious? They plan activities. They plan alternate ways to do things. When we tell them not to do it one way, they'll do it another way. I think they're conscious.
Yeah.
Is a dog
They're
conscious?
thinking.
Yeah, and then you just move right down from there. Is an earthworm conscious?
I have no data on that.
Right, yeah.
I don't know any personally.
Right. I don't know that there's a clear, crisp, conscious, unconscious, or non-conscious
Right, but
distinction.
it would be wrong, though, to say that only human beings can think.
I would certainly say that. That would be-
Mammals.
Yeah.
Would you limit? I mean, earthworms, that's a reach. But mammals, would you say that all mammals have a certain level of thought?
Probably. I worked with fish for 6 years, training fish back in the day, and these fish had individual personalities. They were more sort of braver, more exploratory fish. They were very timid, shy fish. These fish, I believe, were thinking on some level. And fish are thinking, I mean...
I once asked a state aquatics scientist, you might know him, I'm not sure he's there anymore, about whether fish had rights. And he said, of course they have rights. Fish have rights. You can't torture fish.
Right.
You can't hurt fish. You can eat them. But anyway, Radiolab had this really interesting thing about thought. And the Radiolab is on at 10 o'clock in the morning every Saturday on NPR. And it's really, really good. And so are we, but we could get some signals from them. They do a lot of this neurological science.
Oh, excellent.
And one show, I must have been about a month ago, that really caught my attention, was they addressed, some scientist had an idea that you couldn't think, human beings couldn't think unless they had words.
Yes.
Because you need words to define concepts. It's like code. It's like code in computer coding. You have to have symbols, and the words are symbols signifying something conceptually. It could be an object, but it also could be a concept.
Right.
Okay, and you couldn't think in those terms, literally terms, unless you learned the words. So then they made a comparison to see that in societies where the words were learned early, the thought process would start early. In situations where kids didn't get words, didn't go to school, nobody talked to them.
Right.
Nobody talked to them. They didn't have the words, and therefore they couldn't think.
Right.
You buy into that, Ethan?
That's a very interesting concept. Certainly, there's the latter part of what you said. I very much agree. There is a great deal of evidence that the early experiences have profound impacts on shaping your nervous system, and can prevent you from reaching your learning potential. Certainly, if you are kept in a subpar environment in your early ages. Yes, you may later learn to speak. You may be able to converse. But if you have been closed off from that for a long while, you probably are not ever going to function the way you ought to function.
Yeah, deprivation.
Right.
I mean, that shows on the flip side that in order to continue to think, in order to have a reasonable consciousness, you can't have deprivation. You can't be deprived of human contact. Why? Because aside from the emotional aspects, human contact is the exchange of terms, of words, of symbols that represent ideas, concepts, and objects. you know.
There's very interesting data how that aspect of our lives correlates with sort of socioeconomic status, because typically parents in higher socioeconomic levels talk with their kids much more. They use many more words. They use a much broader range of words than do people of low socioeconomic status. And it is believed that this, of course, greatly advantages the kids of those higher socioeconomic level parents when they enter school. These kids know more words, they know more concepts, they've connected more things, basically. And to sort of take your position, that you might say they're a little more conscious in some sense. But it's,
I remember we had a dictionary in our bathroom, and you were expected to read the dictionary while you were in there.
Dictionaries make good reading, you know?
Learn the words. I mean, that was a little strange looking back, but there was value to it. The other thing is that if you say that people who have a rich vocabulary at home with their parents, whatnot, are going to have more words, therefore more symbols of thought, all that. But what about somebody who speaks another language? A language that is richer, arguably richer, that has more vocabulary, more more connections, linguistic connections, or one step further, a person who speaks multiple languages, multiple words representing the same idea.
So there's wonderful work done a few years ago at the University of Washington. Patricia Kuhl, Andy Meltzoff did this work, summarized in a wonderful book called The Scientist in the Crib, pointing out that infants are, as Patricia Kuhl puts it, citizens of the world. They can literally hear and discriminate every sound that is made by every human language on Earth when they are born. They're perfectly good at doing this kind of discrimination, but no one grows up hearing all those sounds, right? They hear the sounds of the one or maybe two or maybe three languages that are around them, and they don't hear the other ones. And by the time they're 8, 10 months old, they no longer can hear those other sounds that they haven't been hearing. They learn to focus and to hear just those sounds that are meaningful they hear. The brain basically has a use it or lose it kind of philosophy. That's the wire.
That's too bad.
So, well, it is, but otherwise we'd be overwhelmed. I mean, it's really got to be that way.
I get overwhelmed even without that.
Right. And so, kids, there is now great evidence that it's very good to teach kids multiple languages, that they should learn second languages and third languages right alongside their first language.
Someday they will, we'll have to. Or we'll have to give up a lot of languages.
Right. Apparently, such kids sometimes lag in the early years a little bit in their primary language skills, confusing words, dropping words from other languages, but typically by the time they're in the middle of elementary school, they've really caught on to that. They know now how to use them. And there's evidence that people who are multilingual do much better as older adults. They stay more flexible, their brains continue to work better, they do not tend to get senile dementias nearly as frequently. So it looks like bilingualism, the ability to make many words, use many different concepts and link them, is probably a very powerful fountain of youth, as it were.
It's comforting in some ways, but in other ways, I wish I had known this 20 years ago, maybe 40. Okay, we're gonna get flexible and we're gonna deal in different symbols. We're gonna take a short break, is what I mean. This is Ethan Allen over here. He's the host of Likable Science, and we're sort of exchanging today. We're talking about learning, and we're gonna be right back after this short break. And when we come back, there's gonna be a short test.
Aloha, I'm Hunter Hevelin, host of Sustainable Hawaii here at ThinkTech Hawaii. You can tune in every week on Thursday at 2 p.m. to see interviews with sustainability professionals from around the state and even further abroad, learning about activities with water management, food security, waste management, and a whole host of other fascinating opportunities to get engaged with making a greener island. So if you're interested in making the transition from consuming individuals to communities of producers, check us out every Thursday. Aloha.
Okay, we're only kidding about the test. There's no test here. Just between us. So, but in the break, we were talking about, another kind of thinking. Maybe it's not the same, and it's the Rain Man kind of thinking, the mathematical thinking, where you're dealing in maybe different symbols, and you can be a great mathematician, but not be able to articulate your thoughts. like Rain Man, like Dustin
Right.
Hoffman, if you remember that
Right.
fabulous
Yes,
movie.
excellent movie.
Really taught us a lot.
Right. Similarly, Oliver Sacks, a psychiatrist, wrote a great book called The Man Who Mistook His Wife for a Hat, which itself is a good story within that. It's a book of stories about interesting people who he has run into in his career as a psychiatrist. He talks about these two twins he ran into in an institution for sort of feeble-minded twins, who were barely verbal, 7 or 8 years old, had a few words, but basically couldn't do much apparently. And at one point he runs into them and they're sitting in a corner, and one would spit out a string of 5 numbers, and the other would sort of smile and nod and drool and give 5 numbers back. And Sachs was interested. They were exchanging why 5 numbers. And so he wrote these strings of numbers down and went to his book of standard mathematical tables and began looking, trying to figure out what they were. He noticed right away they're all odd numbers, which struck him as very strange. And he found out these kids were exchanging 5-digit prime numbers. That is, numbers that cannot be divided into anything else. Now, I couldn't tell you a 5-digit prime number if my life depended on it, nor can probably 99% of the world.
Oh, well, they don't know what it is.
Yeah, many people don't. So Sachs, being the scientist he is, got out his little book. When he next saw them doing this, he dropped in a 6-digit prime number into their conversation, and they both looked at him and sort of smiled and drooled and began exchanging 6-digit primes.
Oh,
And went on 7, 8, 9. His book gave out at 10, and they went on and were exchanging 11 and 12-digit long numbers that were apparently prime numbers. They learned the landscape of numbers in some way that is completely foreign to the rest of us. I mean, they have huge number crunching computers to work on this kind of stuff.
That reminds me of something that they used to say, which I'm sure you'll agree with, is we don't know the half of it.
Oh.
We don't know how powerful the human brain is because we only use a small fraction of it.
Well, we use a lot of it. It turns out the human brain can do absolutely
Speak for yourself.
amazing things. If you look now in these days of functional MRI and all, we do see that a lot of activity bounces around in a lot of places. How well people use it, that's certainly questionable. But yes, there certainly are tremendous potentials of the human brain that are as yet, I think, untapped.
I suppose there's different parts, anatomically,
Absolutely.
of the brain to do certain things. I mean, for example, language
Right.
would be in one part. I think that would be your near logic, but I'm guessing here. Recollection of language, that would be close to language. Math would be in some other place.
Right, and specific
Prime numbers would be near math.
Well, specific lesions in the brain will, of course, knock out certain abilities. People will get a small lesion, a small fault, puka, as it were, in some part of their brain, and perhaps, yes, they can no longer speak, or they can no longer understand language, although they can still emit it. There was a classic case of an artist who was famous for doing big, brightly colored painting, just vivid colors, had a small stroke in a part of his brain, lost the ability to see color, lost the ability to think about color, had to completely reinvent his art around black and white, because
But he still had the art.
he still had the art, but he had color was just
So
no longer
interesting.
part of his universe at all.
They say they've mapped the genetic patterns and chromosomes and genes and DNA and all that. Have they mapped the brain? I mean, can you tell where these centers are?
There are some rough maps of the brain. They're working on this all the time. There's actually a huge brain project going on now for the next several years of trying to get more people working together using better tools to find out how the genes and the proteins that the genes are producing are working in certain parts of the brain, to find out just really on a much deeper level what makes the brain tick.
So there we were in school, way back when. And the teacher said, 2 and 2, Ethan, is 4. I'm telling you this. When I say 2 plus 2, you say 4, okay?
Right?
Now, that has to be memorized somewhere, okay? And we're talking about really, basic, fundamental things here in terms of thought process, but how does that get recorded? I mean, see the brain, for example, as a computer. Somewhere on the hard drive, it's going to have 2 and 2 is 4. Where is that?
Well, that increasing, I think, is recognized as not a particularly good analogy. Our brains don't really work like computers. They really work or if anything, they work like a whole bunch of computers all wired together in parallel, There isn't a discrete 2 plus 2 equals 4 spot in your brain. indeed, what you ideally want to do is teach kids that concept about what 2 + 2 really means. That is 2 things and 2 more things, and that now is 4 things. And that concept will be linked in multiple ways, seeing the numbers, seeing sets of 2 and 2 objects. And the more ways that people can access that, turns out, the better they know it, the more they remember it. If they can.
You're talking about the ideal, though. You're talking about thought.
Right.
I'm starting very low.
Okay.
I say 2 and 2 is 4. You don't have to know why.
Right.
You don't have to know about advanced mathematics.
Right.
Just trust me. 2 and 2 is 4.
Right.
That's what the teacher is saying in the 2nd grade or whenever it is. Okay, where does that go? Is it biochemical? Is it electrical? Is there a little bit thing in your head that keeps that?
Well, all your neurons, I say all, virtually all, work with what are called neurochemical junctions, synapses. So a neuron connects to another neuron at a little point called a synapse. At that point, it dumps out chemical messengers, which then excite a spot on the corresponding neuron that allows that neuron to fire, and that repeats. It's a seemingly actually a very slow and inefficient process because it requires this release of chemicals, this absorption of chemicals, and then an electrical impulse that has to be repeated down a chain. And it's what chain is followed, or more accurately, what web of neurons follows that determines how that is encoded in your brain, how it is then memorized. And if part of that web gets disrupted by an accident, an injury, you may lose that, and you may no longer remember
anymore that 2 and 2 is 4.
Right, exactly. It is surprising both how much of your brain can be lost at times and how much you can still function, and the converse is also true. Sometimes people can have minute, seemingly tiny brain accidents that render them
Like mini strokes.
that
kind
can
of thing.
completely destroy huge amounts of their intellect, their minds. You know?
Yeah. But going back to what's being destroyed, is that a neuron? What is a neuron? Is a neuron the place where the chemical lives, and the combination of chemicals at an atomic level, I mean, or a very microscopic level remembers these kinds of things? Does the chemical set up so it says 4?
So neurons are basically just little cells, and most of them are very multi-purpose. They're involved in many, many different circuits. So those same neurons that are involved in 2 + 2 = 4, some of those neurons are probably involved in, that's a green wall, that's Joe over there. Now there are some neurons that are quite specific, and either they will fire only when they see motion going this way and not motion going this way. There are some neurons that are called face recognition neurons. It turns out faces are very important to us, and there are a select population of neurons that recognize individual faces, and that is, I could look at you this way, or you could be turned half away from me, and the same neuron would code that and say, that's Jay Fidell's face in my brain.
We learned that as cavemen in order to survive.
Yeah, exactly.
It's one of those many, many survival techniques.
Right. Learning that human faces.
If you didn't get it right, maybe your life was forfeit.
Right, exactly.
Because you have to know between friend and enemy.
Right.
Whether he's going to help you or hurt you.
Exactly. Exactly. Why we're also very good at reading expressions, because those are, again, highly predictive of very life important events.
That's why we have these incredible powers, which we don't often use to read people, to know what's on their minds.
Exactly.
Which goes back to a point I wanted to make with you about consciousness. I have a puppy. My puppy will always be a puppy. It's like 3 years old now. It's a she. And she looks at me, and I look into her eyes, and she looks into my eyes, and we hold the glance, and I swear she's human. I swear she's thinking. There's no question in my mind that she has consciousness.
Right.
It's not the same. Go ahead.
She doesn't need no words, right? You can say certain words to her. You can say, get my slippers, and she will go get your slippers, presumably. Dogs are a very interesting case. It turns out from early puppyhood, even pups that have never seen people before seem to have an instinctive, an inbred recognition of the importance of people and the importance of what people look at. So if you take a puppy who's never seen a person before and you look over this way, that puppy will turn and he'll look exactly where you're looking. Wolf cubs won't do that. Fox pups won't do that. Domestic dog pups will follow people's gaze perfectly. Because,
Also survival.
because yes, they have been domesticated. They have learned that we are very important aspects of their environment, that people are.
And when you say learned, you mean learned at genetic level.
Yes, basically.
Because men and puppies and women and puppies,
Right.
you know, have existed for tens of thousands
Right.
of years.
Right.
And we have both, you know, been bred to appreciate the other one. We
Right.
are symbiotic
In that sense,
in the
yes.
cave, in the cave.
Right. Not so much with cats, probably.
No, no.
Yeah, yeah.
So, okay, so we know we have consciousness, and we know that we can stamp 4 on something in the brain and hold on to that. Now, suppose I come to you and say, Ethan, when I told you in the 2nd grade that it was 4, I was only kidding. 2 and 2. 2 and 2 is really 5. And I want you to learn that.
Right.
I'm telling you to memorize 5
Right.
instead of 4. What happens?
Well, then you have to, yes, you set up a new web in your brain now with this new information saying 2 and 2 is 5. And you hope that your old web of 2 and 2 is 4 gradually fades away from disuse. That's not always a very efficient process. Again, as it gets to be important biologically, you can have that kind of learning occur very quickly. If you taste a new flavor, say that you've never eaten a cherry before, you eat some cherries and you get violently ill, and the next time you begin to taste cherries, you will stay away from them. You will not eat them because you have learned that the cherries make you ill and are potentially very dangerous for you. And that's called one-trial learning. And with certain things, taste aversion is a classic case of one-trial learning, where people can learn a new skill with just a single incident.
But some things taste bad intuitively. This is like maybe the dog who looks away or looks with you because he might have learned that, or she might have learned that in the moment, in his or her life with you. But his predecessors might have learned that a long time ago.
Right.
So he knows to look the same direction. The same thing with something that's really distasteful. It could be that your ancestors, Ethan, they had a bad cherry, okay?
Right. I mean,
And they learned it at a DNA level, that cherries that taste that way they're gonna kill you.
right. We don't tend to like bitter flavors. Virtually no one really likes bitterness beyond a pretty limited level, because it turns out many very bitter things are actually very toxic to us. And humans pretty much across the board tend to avoid them, you know. Yeah, it is, again, something that was probably selected evolutionarily, that an ability to both taste and interpret bitterness as an unpleasant stimulation, yeah.
And sometimes you're faced with, well, you know, but bitter, I want you to have the bitter. The bitter is medicine. It's
Right.
castor oil.
Right.
It may not taste very good.
Right.
It may run against your DNA taste.
Right.
But I'm telling you, this is good for you.
Yeah, absolutely.
So you have to override that.
Yes, yeah, and that gets to be.
And the other thing you were talking about is forgetting. I just want to touch on that for a minute. Forgetting. You know, I heard recently that, in fact, it was on 60 Minutes last Sunday, there's a scientist working on cancer. And he's determined that the problem is, I think he's Korean or Chinese. He's an American, and he's done incredible things in LA. And he was the subject of one of their stories. And one of the things he said is people see cancer as a wild cell, a cell out of control. But they should also see that cell as a cell whose time has come, but it didn't leave. In other words, the problem is that all cells must renew, must die. And cancer cells are cells that refused to die. And they create a problem because they're out of control. They should have died, and they didn't die. So it makes a mess. And really is parallel, in my view, to the value of forgetting. Some things you want to forget. You don't want to have an ongoing consciousness about some things because it's too painful.
Well, yes, and they're actually working on forgetting strategies for people with post-traumatic stress disorder, for instance. But it comes up actually as we all get older, and people talk about having senior moments and not being able to function quite as well.
What?
For instance, can you tell me the name of your first grade teacher?
Yes, I can. Mrs. McNally.
Jay, you don't need that information anymore, right? It's no longer relevant to you. That should have somehow been discarded. But yes, because that person was important in your life, you tended to remember, and to this day you remember, even though it has no survival value for you now, right? And it's taking up valuable connections. It's a huge network of your neurons that have Mrs. McNally, you know.
Isn't that amazing?
plugged on in.
You forget things, which I had lunch yesterday.
Right.
But I remember my second grade teacher was Mr. Fanning, who I thought was great. And on that note, we're going to take another break. That's Ethan Allen. He's the host of Likable Science. I'm Jay Fidell, and we're talking about learning. We're having a good time as usual. We'll be right back after this break.
Hi, I'm your host on ThinkTech Asia, Bill Sharp. I look forward to you joining us each Monday between 4 and 5 o'clock when we film right here in our studio in downtown Honolulu. The show, ThinkTech Asia, focuses on contemporary events in Asia. And by Asia, we mean anything from Hawaii, south to Australia and New Zealand, west to Pakistan, and as far north as the Russian Far East. Clearly, this is one of the most economically dynamic centers of the world, and we bring you up to date on what's going on in a whole host of countries in this very vital region. We look forward to seeing you. Aloha.
Okay, before we forget, that's Ethan Allen. He's the host of Likable Science. I'm Jay Fidell. I think I'm Jay Fidell. It's been pounded in at some level. You could probably convince me otherwise if you worked on me. Or tortured me. We're going to get to that.
That's right.
But I had a teacher in junior high school named was Mr. Palmieri, and he was Italian. I mean, born in Italy, spoke Italian. And he always said, and I'm quoting, repetitio mater studiorum, which means, of course, that repetition is the mother of study. So if you want to teach somebody about 2 and 2 is 4, just tell him 1,000 times, and he'll get it for sure.
Right, or better yet, have them repeat it back to you 1,000 times.
Well, that's part of learning too, isn't
Right.
it? It's the confirmation step, the engagement.
Right, it's looking at material, reading it, repeating it back, thinking about it from a different context, taking that material and putting it into another larger piece of material. That kind of stuff is what really makes things sink in and stick with you and become part of your brain. And that's why, yes, your early teachers were important people in your life for long periods of time when you were learning lots of other things, right? So they are hooked in a lot of networks in your brain, basically, which is why you don't forget them, even though they're now sort of worthless information for you.
No, I can't remember lunch yesterday, but I didn't have lunch yesterday. But I can remember what Mr. Palmieri said to me on a regular basis, and other teachers like that.
Right.
So if you take, let me take my 2 and 2 thing just a step further.
Sure.
So you're now in the next grade, and I say 2 and 2 is 5. Trust me on this. It's not 4. You know, God, I'll never forget. We got into college. Short story, and I'll stop. We got into college, and I'll think of his name in a minute. He was wonderful, and he talked about Louis XVI. It was his first day in college, and he mistakenly referred to Louis XVI. Pine was his name. Professor Pine. He mistakenly referred to Louis XVI as a she, okay? And one of the guys in the back row caught that. Good, he was in college now. He was showing how much he knew. He said, Professor Pine, you referred to Louis XVI as a she. That's wrong. Louis XVI was Louis. He was a man. He was the king of France. He wasn't a she. And Pine, without hesitation, said, this is your first day in college, and you are going to learn that some of the things they taught you earlier are wrong.
Not that one, but some of them that was.
And if you hadn't heard before, yes, Louis XVI was a she, and that's why I referred to Louis XVI as a she. And he sucked this guy in, and the guy bought it, okay? Of course, at the end of the class, Professor Pine explained that no, he was just showing us something. But I think there's a worthy lesson there. So somewhere along the line, you've got to say, wait a minute, you said 2 and 2 was 4. It's not 5. Now that's thought process.
Right.
It's different. We're on another level of activity here.
Right. Simple memorization can get you so far. You can, in theory, memorize a whole book in a language you do not read or understand at all. You can memorize it and verbalize it back. Doesn't mean you've really learned anything other than to make those sounds. Nah, not much.
No, not much.
You know, whereas if you actually learn that language, you have this rich way of communicating. You probably have new concepts, alternate ways of thinking about things. Yeah.
So now the young fellow who says, wait a minute, I thought Louis XVI was, you know, a man, or you told me that it was 4, not 5, he's thinking. He's making a comparison. There's a logic tree there.
Right, right.
And, you know, it could be pretty fundamental, but it is Aristotelian logic. He's exercising the thought process.
Right.
So what is that? Where does that live in the brain?
Well, again, that's very fundamental. Even young infants, they actually test young infants' learning by having sort of incongruous or unexpected events. And young infants will pay attention to those when they expect to see, for instance, if a rabbit goes behind a barrier and then a rabbit comes out, and a rabbit goes behind the barrier and a rabbit comes out, and a rabbit goes behind the barrier and a duck comes out. The kid is going like, wow, what's that? That was unexpected, you know?
Yeah.
And so they can tell, yes, that kid is thinking in that sense, in very much the same way. That the kid is sort of, no, I'm not, you know, this is now not congruent with my previous experience, you know? So it's very similar. It's a very fundamental process of pattern recognition that underlies essentially all human learning.
But it's recognizing the distinction. I mean, it's like, he's stopping. He says, wait, something is funny here.
Right.
So there's a thought process.
Right.
Okay, now I want to take you to, you know, the sort of another whole level.
Okay.
And maybe, you know, we could make this in the next grade. Professor says, how much is 2 and 2? And the kid says 6. Okay, now he's lying because they told him it was 4. They changed his mind, maybe, that it was 5. And now he comes up with 6, which he knows in his heart, he knows that's not true. He's lying. So how do we know that he's lying? What is mechanism there? This is really interesting in our time because we have all kinds of issues about torture and trying to get the truth. I heard the most incredible, out of this book I told you about, Barbarity, I think it's Waiting for Barbarity or Waiting for the End of Barbarity. And the quote was so interesting. It said, I never trust anybody unless I know the person spoke under pain. If the person was not in pain, I don't believe him. Which is, that's really, you know, awful. I mean, that is down the path of torture. But let's talk about lying, then we can talk about seeking truth. What happens there when the kid decides to give an answer he knows is wrong?
Right. So for most people, lying, particularly if it's about something important and meaningful, will produce a whole set of physiological responses. And this is why the traditional EEG kind of lie detector machines actually are reasonably good.
Our bodies don't like to lie.
Right, exactly. If you're a normal person, lying will be stressful for you. You will start to sweat a little more, your heart rate will go up, various things will happen, all of which are pretty easy to detect. Now, of course, there is a subclass of people who, you know,
They're good at
pathological
it.
liars.
Those are the psychopaths.
Sociopaths, yes, whatever you wish to call them, who basically can lie about anything at all without, you know, skipping a heartbeat, you know, without raising a sweat at all. And your traditional lie detector will not work very well on those people. And so it's the very people who really most need to know if they're lying, in a sense, are not amenable to our current technologies. There are working on some very interesting technologies now where that essentially can put you in a virtual reality situation, so they could take people back to a scene of a crime, put them in that situation, and your brain on some levels reacts very differently to novel situations versus familiar situations. And it is thought, and this is not well established yet, but it is thought this may be a very powerful technology to determine the truth, because you cannot sort of tell your brain to not, you know, to pretend an old situation is a new situation. You can't. We don't think people can do that. So we think that is, if you showed a crime scene to somebody and they'd actually been in this crime scene, they would, in a sense, have one pattern of firing in their brain, versus somebody who had never been in it and it was truly a new scene for them. Their brains would react a different way.
That probably goes back to the DNA thing, because in trying to survive as a caveman, You had to recognize, like recognizing faces. You had to recognize familiar things.
Right, yeah.
And sometimes it could mean life or death. So we incorporated that into our DNA.
Right.
And that's why the body reacts to a lie.
Right.
Or to a refusal to recognize familiar things.
Right. But yes, it is. The whole issue of lying now is getting to be increasingly tricky. What with the ability to manipulate images on computers now, and you can present anyone doing anything anywhere basically now, and you know, you could say, you know, I have a video of you chopping off somebody's head, and I could probably arrange to get such a video.
Thank you, no.
Right. Yes, that would be a lie on my part. But
Yeah.
so yes, we have a very interesting situation, and the need to be able to tell truth from lies is growing all the time. And Stephen Colbert, to the contrary, you know, truthiness is not going to quite cut it. You know.
You know, when we were kids, there were a lot of psychologists and psychiatrists. And I grew up in New York. New York was the land of sociology. Now the only thing sociologists do is they're parole officers or something. You know, that's what their degree qualifies them for. You don't find a lot who actually practice clinical psychology or study the human brain. And the same thing with psychiatrists. I don't think there are that many. Maybe it's just Honolulu, but I don't think there are that many around. And you know, the level of practice and clinical practice that existed in New York City, anywhere in New York City, when I was a kid was ubiquitous, but not here. Then I'm wondering that, you know, over time, maybe we have lost interest in psychiatry, and we have lost interest in clinical psychology, and we don't care about those things as much as we used to. There are ways to make you feel better. There are the opiates of the masses, and if you feel good, you're not going to call the guy up and go see him. You don't need him, okay? And part of that is, may I say, drugs. You know, we have had a biochemical revolution in our lives.
Sure.
Where you can get a drug for bloody anything, especially for your mind. So it's very sophisticated business, and it seems to me you can feel happy, you can feel sad, you can get uppers, downers, you know, whatever you want you can get. It's all there, prescription and otherwise. I mean, soon enough, you know, marijuana is going to be sweeping the West Coast. It is sweeping the West Coast. Makes you feel better. It's a drug. Okay, someday, soon, maybe soon, it'll be here too. There's a bill introduced every year in the legislature for this. Okay, so we have chemical therapy. Okay, this is what happens, and we have a high degree of knowledge, or higher, much higher than we were kids, about how we can affect our state of mind with modern chemistry.
Right.
Why can't we? Haven't we? We used to talk about truth serum. I never believed that anyway. And I think it was debunked, but why can't we have a drug that makes us tell the truth? Why can't we have a drug? I mean, don't we? Maybe we do. Maybe the CIA had. Why is the CIA torturing everybody when they could just get a drug for $1.50 and make you tell the truth?
Well, again, in part, it's because of this incredible complexity of the brain and the fact that it's not like a computer. There is not like a little spot here on a disk that is, you know, the truth about this fact or the, you know, lie. Every, you know, many neurons in your brain are used repeatedly in many different kinds of thought patterns. And so the truth is some odd combination, but, you know, of firing of those neurons in your head, right? And those have very different chemical signatures. They have their whole different classes of neurons. So any drug is liable to be cutting across, say, a group of neurons that use dopamine as a transmitter. That's not going to affect the ones that use other monoamines or serotonin or noradrenaline, whatever. So you presumably could design some drug, but it would have to be a very complex combination of drugs.
And
yes,
different for different people.
It might well be different for
Because all our
different people.
chemistry is different.
Yes, there's a great deal of similarity, but yes, it might have to be different, might have to be fine-tuned. Who knows? The CIA probably has people working on it at this point.
Yeah, it'd be a lot better than going in
Sure.
front of Congress and Dianne Feinstein and having books written about them. Okay, well, I guess we're out of time. Just I leave you with the thought that, you know, sometimes you don't want to get what you wish for. Jim Carrey in that movie Liar, Liar.
Right.
Can you imagine going through life where you compulsively need to tell everybody everything and it has to be true? That might get you in trouble too.
Absolutely, absolutely. What we don't know is sometimes a good thing.
Thank you, Ethan.
Well, thank you,
Great
Jay.
discussion as always.
That's always good.